The nearest star to our Sun is so close, in cosmic terms, that its light crosses the gulf between us in just 4 years, and yet the journey to stand beneath that light would take longer than the span of entire civilizations. Imagine stepping out of Earth's blue cradle and watching the Sun shrink to a single bright coin, then smaller still, until it is only a point among points. We will move through the silent architecture of our solar system, past the heliopause where the Sun's breath gives way to true interstellar night, and learn what it means to measure distance in lifetimes and hopes. What would we see, feel, and leave behind on the way to Proxima Centauri? Like and subscribe if you like quiet journeys into wonder, and join us now on this gentle voyage beyond home. Let's begin. Every beam of sunlight you feel on your skin began its journey 8 minutes ago. But if we could ride that light out into space, chasing its fading warmth, we'd discover just how impossible the distance to the stars truly is. Light is fast, so fast that it circles Earth 7 times in a single second. Yet even at that unimaginable speed, it takes more than 4 years for a single ray to bridge the gulf between our Sun and Proxima Centauri, the next star over. When we stand beneath daylight, we are not seeing the present but the past, a delayed message from the heart of our own star. The sunlight that warms the oceans today was born in the Sun's core more than 10,000 centuries ago, after a long, slow journey from fusion to freedom. Inside the Sun, photons bounce endlessly between atoms, scattering and colliding through layers of plasma. What begins as the violent birth of light in a furnace of hydrogen takes hundreds of thousands of years to finally reach open space. The light that touches your skin today began before the first cities were built, before language took the shape we know now. Each photon is ancient history, still traveling, still carrying the memory of the moment it was made. If we could ride that photon outward, past Earth's bright limb and the glittering satellites in orbit, we'd see the world shrink to a blue bead wrapped in thin white clouds. The moon would fade behind us. The Sun would begin to lose its warmth, its familiar glow thinning into a sharper, colder light. Hours later, the brightness that once filled our sky would dim to a distant lantern. The shadow of Earth would fall away, and we'd enter a realm where the stars no longer twinkle, where their light travels unbent by air. The further we drift, the slower time feels. There is no sound here, only the steady hum of the cosmos itself, too low for ears to hear. And yet, even in this silence, light speaks. It tells us where it came from, how long it traveled, and what it touched on its way. Scientists use that language of light, the way it bends, scatters, and fades, to read the secrets of the universe. A spectrum can tell us what a distant star is made of, how fast it moves, and whether a planet orbits in its glow. Every photon carries a signature, like a cosmic fingerprint. But light, for all its speed, is finite. Every step farther from home turns warmth into memory. The farther we go, the longer the delay between cause and effect, between the moment something happens and the moment we see it. To look at the stars is to look backward in time, to witness not the universe as it is, but as it was. The night sky above you is a museum of vanished moments, shining in eternal replay. So, when you lift your eyes to the Sun tomorrow, remember, its light is a message that began before you, travelling faithfully through emptiness just to arrive. Each golden ray is both departure and return, proof that even when light leaves us behind, it never truly disappears. It simply keeps going, carrying our story with it, across the endless dark. Proxima Centauri, the nearest star to our Sun, shines from only 4.24 light-years away. A cosmic neighbour by astronomical standards, and yet, if we left tonight, we'd arrive long after 10,000 generations had passed. 4.24 light-years. Sounds small, almost friendly, a number that fits neatly into conversation. But each of those light-years stretches nearly 10 trillion kilometres, a gulf so immense that even our fastest spacecraft, the Voyagers, traveling at over 60,000 kilometers per hour, would take more than 75,000 years to reach it. The light from Proxima that glimmers faintly in our telescopes tonight began its journey when the first powered flight was still only a dream. That light is ancient history already, carrying across the dark to tell us what the star looked like long before any of us were born. Proxima Centauri is part of a small stellar family, a triplet bound together by gravity. Alongside Alpha Centauri A and Alpha Centauri B, two golden stars like our own Sun, Proxima orbits at the edge of the system, a quiet red ember circling far from the warmth of its larger siblings. It is smaller than our Sun, cooler, dimmer, and more temperamental. Yet it is ours in a way no other star is, because it is the closest. The first step beyond our solar neighborhood, the first destination written on the map of forever. When we look toward Proxima, we are staring across the deep interstellar medium, the thin, invisible ocean of gas, dust, and magnetic fields that fills the space between stars. It's a desert so empty that the average distance between two atoms is greater than the width of a football field. And still, it is not nothing. Within that emptiness float the raw materials of creation, hydrogen, carbon, oxygen, waiting for the slow work of gravity to weave them into new stars and planets. The same elements that built us drift there, unclaimed and eternal. If we could somehow make the journey, if we could cross that abyss in a single lifetime, we would find Proxima to be a restless light. A red dwarf star, it flickers and flares, releasing violent storms of radiation that can strip the air from any nearby planet. Yet its faint glow burns for trillions of years, far longer than our Sun will ever live. In the long future, when our own solar system has cooled to ash, Proxima will still be shining, dim but enduring. The irony is humbling. The closest star to us is unreachable with today's engines, its warmth untouchable, its light a distant whisper. And yet, it watches us constantly, its faint red glow forever mingling with our dreams of crossing the void. The distance between Earth and Proxima Centauri is more than physical. It is philosophical, a reminder that even our nearest neighbour exists on a scale far beyond human instinct. We measure it not in kilometres or years, but in imagination, the one form of travel fast enough to bridge the impossible. When we gaze at Proxima's tiny point of light, we are already partway there, carried not by rockets or sails, but by the quiet certainty that one day, somehow, we will find a way to reach it. Leaving Earth is not an act of escape, it's an awakening. We rise above the thin veil of atmosphere that has cradled every breath in human history, and see our planet as a single shimmering reflection of home. The journey begins not with engines or coordinates, but with perspective. As the blue fades beneath the window of a spacecraft, the familiar horizon curves, and for the first time, Earth reveals its true shape, a fragile sphere floating in the infinite dark. Clouds swirl like brushstrokes of white paint, and continents glow faintly under the thin golden rim of sunlight. It is beautiful, yes, but also impossibly small. The realization comes quietly, like breath against glass. This is everything. Every song, every sunrise, every moment of joy or grief has unfolded upon that tiny glowing world. The higher we climb, the thinner the air becomes until there is none at all, only silence and starlight. From orbit, night and day lose their meaning, shadows stretch endlessly, and sunlight burns without mercy. Our planet turns beneath us, a living marble wrapped in movement, storms twisting over oceans, lightning pulsing across continents, the faint glimmer of cities like scattered embers in the dark. Looking down, it is impossible not to feel both love and humility. We are the caretakers of something delicate, suspended between the heat of the sun and the cold of eternity. Crossing beyond Earth's atmosphere is like stepping over the edge of an ocean we never knew surrounded us. Astronauts often describe this moment as the overview effect, a sudden awareness that all borders are illusions, that humanity is one species sharing one home adrift in space. From this vantage, war seems absurd, politics small, and life itself precious beyond measure. It is as if the universe lifts us gently and whispers, "See clearly now." Beyond the exosphere, gravity's grip loosens its hold. Satellites drift like silent lanterns, tracing invisible lines around our planet. The International Space Station glides by, a fragile outpost where human voices echo in a place no human was ever meant to live. Beyond that lies the domain of the Moon, our first and only natural companion, circling in quiet loyalty. Every journey outward begins here, in the soft glow of reflected sunlight on lunar rock. But the solar shore doesn't end at the Moon. It extends through the invisible tides of Earth's magnetic field, across the orbits of artificial satellites, and outward toward Mars, Jupiter, and the edge of the heliosphere. Leaving Earth is only the first step, a small, trembling gesture against a backdrop of infinity. Yet within that step lies everything that makes us human. Curiosity, courage, and the desire to see what lies beyond the next horizon. When we look back at Earth from that distance, it doesn't shrink our importance, it expands our connection. We see, perhaps for the first time, not separation, but unity. Leaving home teaches us what home truly means. And as we drift farther from its light, we begin to understand exploration isn't about escape from the world below. It's about carrying its light with us, a promise that wherever we go in the universe, a part of Earth will always go too. Beyond the Moon and Mars lies a realm where sunlight fades to silver. Out here, radio waves stretch thinner, and silence begins to hum, the soundless vibration of distance itself. The solar wind still breathes faintly from the sun's corona, but it grows weaker with every million miles. Its warmth dwindles into a pale echo, a whisper carried by particles too sparse to touch. The light that once painted Earth in colour now becomes cold, a diluted memory stretched thin by space. Shadows have weight here, and silence has shape. It is not an emptiness, but a vast stillness, a cosmic calm that feels almost sacred. Between the worlds, there is no wind, no rain, no sound. Even the idea of sound breaks down, for sound needs air to travel, and air does not exist here. What moves instead are fields, magnetic, gravitational, and electric, threading invisibly through the void. They bend around planets, spiral from the sun, and drift toward the interstellar medium. We cannot hear them, yet our instruments can feel their rhythm, the pulse of plasma, the heartbeat of the heliosphere. This is the realm where our robotic explorers now drift. Voyager 1 and 2, tiny ships launched in the late 1970s, continue to glide through this quiet sea. Their antennas still whisper faint messages back to Earth, each signal taking more than 20 hours to arrive. The photons carrying their words are so faint that the deep space network, vast dishes across 3 continents, must listen harder than any human ear ever could. Each transmission is like a message in a bottle cast into an endless ocean. And yet, against all odds, the bottles return. Out here, the silence isn't empty, it's alive with subtle motion. Streams of dust drift through the dark like invisible rivers. Each grain, smaller than a speck of smoke, moves in a pattern that echoes the memory of ancient collisions. The remnants of comets, the ashes of asteroids, the fragments of what once might have been worlds. Occasionally, one of these tiny particles collides with a spacecraft, creating a microscopic flash of light, a brief reminder that even in nothingness, something always moves. The sun still shines behind us, but its authority fades. Daylight becomes a distant concept, night becomes everything else. The stars grow sharper, more numerous. The Milky Way stretches like a ghostly ribbon across the void, no longer a band of light but a vast structure of billions of suns, each one a destination, each one a dream. If you close your eyes and imagine standing here, somewhere between Mars and Jupiter, the silence becomes its own kind of music. You begin to sense time stretching, seconds turning into minutes, minutes into years. Space has no edges here, only gradients of distance and light. The human sense of scale fails completely. Traveling through the quiet between worlds is like walking through the memory of creation itself. You realize that everything, the stars, the planets, even you, was forged from this same silence. And as you drift onward, deeper into it, you understand the universe does not shout its wonders, it whispers them. And only in the quiet can we truly hear. We cross the final frontier of our solar system, where Neptune's faint blue glow gives way to the black sea of interstellar space. Behind us, the sun becomes a star among stars. Out here, Neptune no longer looks like a planet. It's a blue coin suspended in the dark, its methane clouds swirling slowly above frozen winds that roar at more than 1,000 miles per hour. The last giant of our solar family, it guards the boundary like a silent sentinel, keeping watch over the edge of sunlight. Beyond it lies the Kuiper Belt, a drifting cathedral of ice and stone, remnants of the solar system's creation, untouched for billions of years. As we move past Neptune's orbit, the light from the sun fades to a dim spark, too weak to cast shadows. The warmth we once took for granted now feels distant and mythical. If we reached out a hand, the cold would bite through even the thickest protection. At this distance, the sun's power, the force that drives every storm, every tide, every heartbeat on Earth, has dwindled to a gentle whisper, barely enough to touch our instruments. The Kuiper Belt is a cosmic graveyard and a nursery all at once. It's where ancient objects sleep in elliptical silence, worlds like Pluto, Eris, Haumea, and Makemake, frozen relics carrying the chemistry of beginnings. Each of these icy bodies tells a story of the early solar system, when dust and gas condensed into worlds. Their surfaces, coated in nitrogen frost and hydrocarbon snow, reflect the faint sunlight like old glass. To see them is to look backward in time, into the memory of our planet's own birth. Beyond this region lies something even more mysterious, the scattered disk, where the sun's gravity starts to lose its authority. Out here, orbits stretch for centuries, even millennia. Comets sleep in elongated paths that will one day bring them back toward the inner planets, flashing briefly through the warmth before retreating once more into the dark. Some will never return, cast adrift forever by the gravitational pull of passing stars. When we finally move beyond Neptune's realm, the solar system becomes a memory. The planets vanish behind the mist of distance, and the sun shrinks to a pale star indistinguishable from the others. It's a moment of cosmic humility, the realization that everything we've ever known, every life, every civilization, now fits within a single, glowing point of light. From here, the stars no longer look like ornaments scattered across the sky. They look like destinations. Each one is a sun, perhaps with its own planets, its own stories, its own question marks orbiting in silence. Between them lies the interstellar medium, a thin breath of hydrogen atoms, a dusting of cosmic rays, the faint afterglow of creation. Crossing Neptune's orbit is not the end of our solar system. It is the beginning of the great in-between, the endless bridge that connects one sun to the next. The space beyond is not empty, it is waiting for our ships, our signals, our dreams. And as we leave Neptune behind, we realize the truth. To go farther is not to leave home, but to expand it. At the edge of the sun's influence, a vast invisible bubble of solar wind meets the pressure of interstellar gas. It's here, at the heliopause, that we step into true cosmic darkness, the space between suns. For billions of miles, the sun's breath has stretched outward, a constant stream of charged particles known as the solar wind. It shapes an immense bubble around our solar system called the heliosphere, a protective cocoon shielding the planets from the harsher radiation that fills the galaxy. But even the sun's reach has a limit. Eventually, the outward push of its wind weakens until it meets the faint but steady pressure of interstellar space, a vast ocean of gas, plasma, and magnetic fields that flows between the stars. That border, delicate and invisible, is the heliopause. If you could cross it, nothing would announce your passage. No visible wall, no boundary line. One moment, you'd still be under the sun's faint protection. The next, you'd be adrift in the true interstellar medium, the domain of the galaxy itself. Yet the difference is profound. Inside the heliosphere, most particles you encounter were born from the sun's own fire. Outside it, they come from ancient supernovae, from stars that lived and died long before the Earth even formed. To step past the heliopause is to step into history older than the solar system itself. When Voyager 1 reached this threshold in August 2012, it became the first human-made object to leave the sun's protective bubble. Its instruments detected a sudden change. The solar particles disappeared, replaced by the signature of interstellar ones. The spacecraft had crossed into a realm untouched by our star's influence, a place that had never felt the warmth of sunlight. Its faint signal, taking more than 20 hours to reach us, carried news from a region humanity had never entered before. Out here, sunlight is nearly meaningless. The solar wind no longer rules. Instead, magnetic fields twist and sway according to the grand design of the Milky Way. Charged particles drift slowly, their movements influenced by stars we cannot see. The space beyond is not silent, but filled with a quiet static, the hum of radiation, the echo of distant cosmic rays. It is a symphony, too faint for ears, but not for instruments. Voyager's sensors recorded it as a low, constant tone, the voice of interstellar space. Imagine standing on the threshold, the sun behind you, and the galaxy ahead. Behind lies everything familiar, the planets, their moons, the warmth of day. Ahead is everything else, billions of suns, countless worlds, and the infinite web of starlight connecting them. Crossing the heliopause isn't just a change in location, it's a change in belonging. Inside, we are children of one star. Beyond, we become citizens of the galaxy. This boundary is the true shoreline of our cosmic island. It marks where the tide of the sun ends and the open sea of the universe begins. And though we have only touched it with a handful of machines, one day our descendants may cross it in person, not as explorers lost in the dark, but as travelers returning to a greater home. For beyond the heliopause lies not the end of the sun's light, but the beginning of everything else. Voyager 1 passed this border in 2012, carrying a golden record, Whispers of Earth, encoded in sound and symbol. Every heartbeat, every ocean wave, drifts now toward Proxima's light. In 1977, humanity launched two nearly identical spacecraft, Voyager 1 and Voyager 2, not just to explore the planets, but to carry something far more fragile, a story. Each Voyager holds within it a golden disc, a phonograph record coated in gold, designed to last for 1 billion years. On that record is a time capsule of our world, 115 images, greetings in 55 languages, a selection of music from every continent, and the sounds of wind, thunder, birdsong, and laughter. It is the only human artifact ever designed to outlive the sun. The record begins with a greeting from the Secretary-General of the United Nations, then a heartbeat, the simplest, most universal rhythm of life. There are songs from Senegal, Bach's Brandenburg Concerto, a Navajo night chant, a Peruvian wedding song, and Chuck Berry's Johnny Be Good, a dance of rock and roll sent into eternity. Carl Sagan, who led the team behind the record, called it a bottle cast into the cosmic ocean. It wasn't made for discovery, it was made for hope. Now, Voyager 1 drifts more than 24 billion kilometers from home, traveling outward at over 60,000 kilometers per hour. Its instruments are aging, its power fading, yet it continues to speak, faint radio whispers captured by NASA's Deep Space Network, which must listen harder than any ear has ever listened. Its signal is weaker than the static of a falling snowflake, but it carries meaning, proof that something made by human hands has entered interstellar space. Each second, Voyager sails farther into the night, the golden record turning silently within it. The sounds of rain and waves now move through the cold vacuum between stars. If one day, millions of years from now, Another intelligence finds it. They might decode those grooves and hear the voice of a mother comforting a child, the laughter of friends, the rush of the surf along Earth's shores. In that moment, they would know someone, somewhere, once lived here. But the record isn't just for them, it's for us. It reminds us that even in our infancy as a species, we looked outward. We wanted to be known. We wanted the universe to know that we were not only thinkers and builders, but dreamers. Every beat, every melody carved into that golden disc says the same thing. We existed. We felt wonder. We reached for the stars. As Voyager continues its endless journey toward the constellation of Ophiuchus, toward the general direction of Proxima Centauri, it carries our message. Not a plea, not a question, but a whisper. A heartbeat from a small blue planet, still echoing in the dark. And though no one may ever find it, the act of sending it was enough. Because to speak into the void is to declare that we are alive, and that life, in all its fragility, dares to be heard by the cosmos itself. The path between stars isn't empty. It's a river of charged particles, magnetic tides, and cold molecular clouds. To travel it is to surf the invisible, to sail a sea made of space itself. For centuries, humans imagined space as a perfect vacuum, an endless void of nothingness. But that is an illusion. Even in the deepest interstellar darkness, the universe breathes. The space between stars is filled with a faint, whispering medium, a mixture of hydrogen, helium, dust, and energy fields, so diffused that a single cubic centimeter might hold only one lonely atom. And yet, across trillions of kilometers, that barely there substance becomes an ocean. It ripples, shifts, and flows, sculpted by the gravity and magnetism of entire galaxies. These are the invisible currents of the cosmos. They form an intricate web, a cosmic weather system that no eye can see but every traveler must navigate. Streams of charged particles spiral along magnetic field lines, bending and twisting through the Milky Way. Shockwaves from supernovae send ripples through this medium, stirring ancient gas clouds that may one day collapse into newborn stars. To move through space is to drift across these unseen rivers, each one carrying the memory of creation and destruction alike. Our sun itself sails through this galactic ocean, dragging the planets with it as it orbits the Milky Way at nearly 230 kilometers per second. The heliosphere, that vast bubble of solar wind, acts like the bow wave of a ship, parting the interstellar medium before it. Behind it trails a long, comet-like wake of particles that stretch for billions of miles. We are passengers on this ship, carried through the galaxy by a motion so vast we can only measure it against the stars themselves. Scientists have begun to chart these hidden flows. Using radio telescopes, they trace the faint emissions from hydrogen atoms drifting in space. With spacecraft like Voyager and Ibex, they map the pressure of particles striking the edge of our solar system. The data reveals a landscape that moves and breathes, waves of density, eddies of magnetism, vast clouds of cold gas gliding like icebergs through the dark. The local interstellar cloud, through which our solar system now travels, is a thin mist of atoms stretching 30 light-years across, heated by the ghosts of long-dead stars. If we could see these currents, they would shimmer faintly, ribbons of light and motion twisting through endless night. A ship traveling between the stars would not move through stillness, but through subtle tides. The challenge for future explorers will be learning how to ride those tides, to use them as ancient sailors once used the wind. With magnetic sails or plasma shields, a starship might one day surf the faint breath of the galaxy itself. The map of these invisible currents is still unfinished. It is drawn not in ink, but in radiation, gravity, and time. And like all maps of exploration, its lines tell us as much about ourselves as about the world it describes. Because the more we learn about the invisible, the more we realize the universe has never been empty. It has always been alive, in motion, carrying us quietly along its endless, unseen sea. Chemical rockets burn bright but die fast. To reach another star, we dream of new engines, fusion drives, solar sails, and antimatter hearts, technologies that would turn centuries into decades. The rockets that carried us to the moon and beyond run on simple chemistry, explosions harnessed to fling metal skyward. They are powerful but fleeting, like matchsticks flaring in a storm. Even the mighty Saturn V, the largest rocket ever built, could only push its crew a few 100,000 kilometers from Earth before running dry. But the gulf between stars is not measured in thousands or even millions of kilometers. It is measured in light years, trillions upon trillions of kilometers that no chemical flame could ever conquer. If we are to touch another sun, we must invent a new kind of fire. One possibility is nuclear fusion, the same process that powers the stars themselves. Instead of burning fuel, a fusion engine would merge light atoms, like hydrogen, releasing enormous energy in the process. Imagine a ship propelled by miniature suns, each reaction pushing it faster through the dark. Projects like Daedalus and Icarus Interstellar have already sketched out designs, vast crafts, the size of cities, fueled by pellets of deuterium and helium-3. If perfected, a fusion drive could reach up to 10% of light speed, turning a 75,000-year journey to Proxima Centauri into just a few human lifetimes. Then there are solar sails, delicate sheets of reflective material that catch the pressure of light itself. Though light has no mass, it carries momentum, a gentle push that never fades. A sail the size of a football field could ride sunlight out of the solar system, and if boosted by powerful Earth-based lasers, it could reach 1/5 the speed of light. That's the dream behind Breakthrough Starshot, a real project already in motion. Tiny probes, no bigger than a chip, could be sent across the void, reaching Proxima in just over 20 years. Not crewed missions, but the first messengers between stars. Far more speculative are the antimatter drives, engines powered by the most efficient reaction known to physics. When matter and antimatter meet, they annihilate, turning their entire mass into pure energy. Just a few grams could power a ship for years. But antimatter is rare, difficult to contain, and almost impossible to produce in large quantities. Still, it remains a dream worth chasing, the kind of dream that rewrites what's possible. There are even wilder concepts, warp drives that bend space-time, Bussard ramjets that collect hydrogen from the interstellar medium as fuel, and black hole drives powered by the energy of evaporating singularities. Each one sits at the border between physics and imagination, yet every idea begins that way. In the end, the true engine that could take us there isn't made of metal or fire. It's made of curiosity, the one energy source that never runs out. Every theory, every experiment, every dream of crossing the stars begins with a simple question. What if we could? The stars are waiting, and the equations are written. Somewhere between science and wonder, we are learning how to ignite the next great flame, not one that burns out, but one that carries us beyond the limits of what we thought we were. A photon sail, no thicker than a whisper, could one day ride the pressure of sunlight pushed by lasers from Earth. At 1/5 the speed of light, it would reach Proxima in 20 years, a fragile ship carried by radiance. It sounds like something from poetry, a ship made not of metal, but of light. Yet this is one of the most realistic visions we have for reaching another star. The concept is simple, but profound. Use the momentum of photons, the tiny packets of light that stream endlessly from stars, to push a spacecraft forward. Though each photon carries almost no mass, the combined effect of billions of them striking a reflective surface can generate a continuous, gentle thrust. Like wind filling a sail, light itself can become the engine. Such a sail would have to be impossibly thin, perhaps just a few atoms thick, made of reflective materials like graphene or metamaterials that shimmer between substance and energy. It would unfurl in space like silver silk, its surface wide enough to catch the faintest glimmer of sunlight. Alone, That light might not be enough to send it to the stars. But if we help it with power from Earth, it could ride a beam of pure energy across the void. That is the dream behind Breakthrough Starshot, a real initiative launched by scientists and visionaries who believe we can send tiny interstellar probes to Proxima Centauri within our lifetime. Their plan: use a massive array of ground-based lasers, 100 gigawatts of power, to focus an enormous burst of light onto a fleet of small, sail-driven craft. Each craft would be no larger than a computer chip, weighing just a few grams, but equipped with sensors, cameras, and communication arrays. When the laser fires, it would accelerate the probe to 1/5 the speed of light, more than 60,000 kilometers per second. At that speed, the tiny ships could reach Proxima in just 20 years. They would not carry humans, but they would carry our curiosity, our eyes, our questions, our intent. Each photon sail would be a message of light, carrying data and dreams to another sun. After 2 decades of flight through interstellar space, the sails would pass near Proxima b, snapping images, recording magnetic fields, perhaps even detecting traces of an atmosphere, all before streaming their findings back toward Earth. But there's beauty as well as science in this vision. A ship riding on light is a metaphor for us, for the way humanity moves forward, propelled not by strength, but by persistence. Light never tires. It never stops. It continues to travel, even when no one watches, even when its source has gone cold. Imagine the sight: a silver sail gleaming faintly against the stars, carried on a beam invisible to the naked eye. It glides silently, without exhaust or flame, without noise or resistance, just motion, pure and infinite. Behind it, Earth fades into a memory. Ahead, Proxima grows brighter, waiting like a beacon in the dark. Someday, when those sails finally cross the space between, the first message we receive back will not just be a photograph of another world, it will be proof that light itself can carry life's ambition. That we, small and brief as we are, once learned to ride the very thing that makes the universe shine. Project Starshot is humanity's first real attempt to send a fleet of microcraft toward Proxima Centauri. Each is smaller than a postcard, yet together they represent the first fleet of another star system. It began, as all great voyages do, with a question: what if we could actually go? For centuries, the distance to the stars was a poetic impossibility, something to dream about, not to plan for. But in 2016, a group of scientists, engineers, and dreamers decided to make that question an engineering problem. Their idea was both elegant and audacious. Instead of sending one enormous spacecraft, they would send thousands of tiny ones. Instead of carrying fuel, they would ride on light. Each of these starships would be wafer-thin and incredibly light, weighing only a few grams, smaller than the palm of your hand. Yet within that sliver of technology would be everything needed for exploration: cameras, sensors, navigation tools, and a communication system capable of beaming data across 4 light-years. They would be attached to thin, reflective sails, each one several meters wide, designed to catch the push of laser light from Earth. The lasers themselves would be extraordinary, an array of synchronized beams on the ground, working together to create a single, immense pulse of energy. For just a few minutes, the lasers would fire, pushing the sails to 1/5 the speed of light. Then, the probes would coast silently into the dark, carried forward by the momentum of that single moment. No engines, no fuel, just light, distance, and time. If successful, the fleet would reach the Proxima Centauri system in about 20 years. For the first time, humanity would send physical explorers to another sun. Not human explorers yet, but robotic emissaries of our curiosity. Once they arrive, they would pass near Proxima b, capturing images and reading the faint fingerprints of its atmosphere to search for signs of habitability, or even life. The data would then begin its long return home, traveling across 4 years of space before reaching Earth. But beyond the science, Starshot represents something deeper: a turning point in the story of our species. For the first time, we are planning a mission that looks beyond the solar system, beyond our sun's comforting light. It's the first moment we've looked at the stars not as unreachable dots in the sky, but as destinations. In a way, Project Starshot is a message written in light and ambition. Each probe will be smaller than a butterfly, yet collectively they will carry the weight of humanity's oldest dream, the desire to see what lies beyond the horizon. They will drift through interstellar night for decades, silent and patient, until one day they pass through the faint red glow of Proxima. When that happens, it won't just be the story of a scientific mission, it will be the story of us. A civilization that learned to turn light into a ship and distance into invitation. Project Starshot is not only our first interstellar voyage, it's the first chapter of a new kind of humanity. The light we see from Proxima tonight began its journey when the world was different, when people were still waking from dreams we've already forgotten. Every star is a time machine. When you look up at the night sky, you are not seeing now, you are seeing then. Every gleaming point of light is a delayed message, a postcard from the past sent across the slow currents of space. Proxima Centauri's faint red glow, so dim it can't be seen without a telescope, left its surface 4.24 years ago. That means, when that light began its voyage toward us, Earth was almost 5 trips around the Sun, younger. Somewhere below, seasons had changed, clouds had moved, and billions of lives had gone on, unaware that a soft crimson photon had just set out to find them. It's a strange thought. That light, the fastest thing in the universe, still takes years to reach us from our nearest stellar neighbor. That when we finally capture it with our telescopes, we're seeing not Proxima as it is, but as it was. If a being around Proxima looked back toward Earth at this very moment, they wouldn't see us as we are now. They'd see our planet as it appeared in 2021, before you read these words, before millions of new stories began. Every star is a mirror reflecting history. When we study the galaxies that fill the night, we are peering deeper and deeper into the past, some so far away that their light began traveling before the Earth even existed. The farther we look, the younger the universe becomes, until, in the faintest reaches of infrared light, we see echoes from just a few 100 million years after the Big Bang. We are not merely observing space. We are observing time itself, stretched across a cosmic canvas. Proxima's light, humble as it is, carries with it the signature of its own physics, tiny variations that tell us its temperature, its activity, its flares, its rhythm. When scientists study its spectrum, they decode the language of the star, the dance of hydrogen, helium, and magnetic storms that shape its glow. That faint red beam is more than illumination, it's information. Each wavelength tells a story about what is happening there, 4 years in the past. And yet, there's a gentle poetry in this delay. It means we are always out of sync with the universe, forever seeing it as it once was, never as it is. We live surrounded by ghosts of light, by billions of suns whose messages are still en route, crossing oceans of time. Every night, we stand on Earth's surface and look backward into eternity, bathed in the afterglow of what was. So, when you look at the stars, remember this: you're not looking out, you're looking back. It's a story still unfolding, still arriving, and one day, perhaps, light from our own star, the sun's soft pulse, will reach another world, and someone or something will look up and see us as we were, 4 years, or 4 centuries, or 4 million years ago. In the end, light is the universe's memory, and we are its witnesses. Proxima is a red dwarf, smaller, dimmer, and far more temperamental than our sun. It flares with violent bursts of radiation that could strip the air from a planet in seconds. From a distance, Proxima Centauri appears calm, a faint ember-like glow lost among brighter stars. But behind that quiet light lies a restless heart. Red dwarfs are the most common stars in the universe. making up nearly 70% of all that exist. They are small, steady furnaces that burn their fuel slowly, living not for billions, but for trillions of years. Yet this longevity comes with a price. They are volatile, magnetic, and unpredictable. Proxima's surface, though cooler than our sun's, is a turbulent ocean of plasma. Fields of magnetism twist and snap like invisible storms, unleashing sudden waves of X-rays and ultraviolet fire. In March of 2016, telescopes recorded one of Proxima's largest known outbursts. For a few brief moments, the star brightened by nearly 1,000 times its normal intensity. The flare erupted across multiple wavelengths: visible, ultraviolet, and X-ray. And if there were a planet nearby, its sky would have ignited in a violent red dawn. On Earth, such radiation would burn through the ozone layer and strip away protection from the sun. Around Proxima, it could strip an atmosphere clean, molecule by molecule. And yet, this chaotic energy is also what makes red dwarfs so fascinating. They are paradoxes, small and dim, yet immensely powerful. Because of their low mass, they can burn quietly for trillions of years, far longer than our sun's expected lifespan. When our solar system has long turned cold and silent, Proxima and its kin will still be shining, slow and steady, in the far future of the cosmos. In the timeline of the galaxy, red dwarfs are eternal. Imagine standing on a nearby planet during one of Proxima's calm periods. The light would be dim, bathing the surface in a soft crimson hue. Noon would feel like sunset, the shadows long and gentle. Plants, if they evolved there, might drink in infrared light instead of yellow. Skies would be dark even in daylight, and the stars would never fully vanish. Then, without warning, the sky might erupt, a flare so bright it casts new shadows, its energy rippling through the atmosphere, igniting auroras of deep red and violet that dance across the horizon. Life beneath such a sun would need to be clever. It might hide underwater, or beneath layers of rock, emerging only between flares. Evolution there would not favor fragility, but resilience, organisms that can sleep through storms and awaken when calm returns. On Proxima b, if life exists, it would live in rhythm with a sun that breathes in bursts, where danger and warmth are part of the same heartbeat. Proxima Centauri is not the tranquil yellow sun we know. It is smaller, yes, but fiercer, older, and more enduring. It burns quietly for eons, interrupted by flashes of fury, each one a reminder that even the dimmest stars carry tempests within them. In that soft red glow lies both peril and promise. A sun that could destroy life, or sustain it far longer than ours ever will. Orbiting within the narrow band of warmth where liquid water might flow, Proxima b is roughly the size of Earth, a potential cradle of life circling the nearest sun beyond our own. In 2016, astronomers detected a faint, rhythmic tug in Proxima Centauri's light, a subtle wobble that could only mean one thing. Something was pulling on the star. That invisible hand was a planet, unseen but undeniable, orbiting once every 11 days. They named it Proxima b, and in that instant, the nearest potentially habitable world leapt from speculation into reality. At one point 3 times the mass of Earth, Proxima b belongs to the family of rocky, terrestrial worlds, the kind that can, in theory, hold oceans, mountains, and atmospheres. Its orbit lies within what scientists call the habitable zone, the region around a star where conditions could allow liquid water to exist. But this Goldilocks zone is deceptive. Around a red dwarf like Proxima, warmth comes not from gentle sunlight, but from dim, relentless infrared rays. Daylight there would not be golden, but a deep, ember-colored glow. Standing on its surface, if you could, would feel like standing at the edge of a perpetual sunset. The sky would never turn blue. Instead, it might shimmer in dark reds and purples, the light too weak to scatter. Shadows would stretch long across the landscape, and if Proxima b is tidally locked, as many astronomers suspect, one side of the planet would face the star forever, while the other remains in endless night. The twilight band between, a thin ring of eternal dusk, might be where life, if it exists, could thrive. There, temperatures could balance between fire and frost, oceans might linger, and the air could circulate in slow, planetary tides. Yet Proxima B's story is not one of simple serenity. The same star that gives it warmth also threatens it. Proxima's flares could strip away an atmosphere, scouring the surface with ultraviolet radiation. For life to survive, the planet would need protection, perhaps a thick magnetic field or dense layers of cloud and ocean to absorb the bursts of energy. If it has those defenses, it might be one of the most extraordinary refuges in the galaxy, a living world orbiting a temperamental sun. Telescopes have only begun to study this faint companion. We can't yet see it directly, only infer its presence from gravity's subtle fingerprint. But future missions, like the James Webb Space Telescope and its successors, aim to read the starlight that filters through its possible atmosphere. From that light, scientists hope to find the faint signatures of oxygen, methane, or water vapor, chemical whispers of life. Proxima b is more than an exoplanet, it's a mirror. It reflects our desire to believe that Earth is not unique, that the spark of life could ignite wherever warmth and chemistry meet. In the dark between suns, this tiny world orbits quietly, a promise, a question, a reminder that even in the nearest star's shadow, another home might be waiting. We first discovered Proxima b not by sight, but by tug, the faint wobble of its star, moving ever so slightly as the planet circled it. Proof that even from 4.24 light-years away, gravity still whispers. When astronomers look for new worlds, they often can't see them directly. The stars they orbit are too bright, too overwhelming, drowning their planets in light. Instead, scientists listen to the quiet symphony of gravity, the way a star sways ever so gently when something unseen pulls on it. This method, called the radial velocity technique, is how Proxima b first announced itself. In 2016, using the HARP spectrograph in Chile, astronomers detected an almost imperceptible rhythm in Proxima Centauri's light, a slight shift in its spectrum that repeated every 11.2 days. To the human eye, the star seemed steady, unmoving. But through the precision of modern instruments, it was dancing, ever so slightly, to the gravitational pull of something small and nearby. That something was a planet, no larger than Earth, orbiting closer to its star than Mercury does to the Sun. This subtle dance between star and planet is one of the most delicate measurements in all of science. The motion of Proxima caused by its planet is only about 5 kilometers per hour, slower than a person walking. Yet even that gentle tug leaves fingerprints on the light it emits. As the star moves toward us, its light shifts slightly bluer. As it moves away, slightly redder. These tiny oscillations in wavelength, smaller than 1 part in 100 million, are what revealed Proxima b's existence. Imagine it. From 4.24 light-years away, we can detect the faint gravitational pull of a planet smaller than our own, circling a dim, distant sun. We can feel its presence not through sight, but through motion. It's a reminder that the universe is deeply connected, that every world, no matter how far, leaves a ripple in the fabric of its star's light. And sometimes that light dims. Astronomers also search for planets through transits, moments when a planet passes in front of its star, casting a tiny shadow. Each transit is like a heartbeat, a rhythmic blink of darkness that reveals a planet's size, orbit, and sometimes even the composition of its atmosphere. While Proxima b doesn't appear to transit its star from our viewpoint, others do, and through those shadows we've found thousands of exoplanets, each one a world with its own weather, seasons, and stories. The beauty of this method lies in its subtlety. We don't need to see a planet directly to know it's there. We can sense it through the star's hesitation, through the faint gravitational whisper that crosses the light years between us. It's a cosmic form of listening, one that transforms the universe into a living map of relationships, where every star tells us about the company it keeps. Proxima b was found in that way, not by light, but by shadow. A soft, invisible nudge that said, "Something else is here." And in that whisper, humanity heard something profound, confirmation that even the nearest star harbors worlds of its own. The universe, it seems, is far from empty. It is full of companions, orbiting in silence, waiting for us to notice their gentle pull. If Proxima b has an atmosphere, its skies might glow dim crimson, its days short, its nights long, but just warm enough for oceans to dream beneath alien suns. In the fragile equation that defines habitability, temperature is everything. Too hot, and oceans boil into vapor. Too cold, and water freezes into unyielding ice. But somewhere in between, in that narrow range of cosmic balance, liquid water can flow, and with it, the chemistry of life begins to stir. Proxima b, orbiting within this delicate band around its small red star, sits tantalizingly close to that threshold. It may be a frozen desert or a living world warmed by the dim fire of its parent sun. Because Proxima Centauri is so faint, its habitable zone lies far closer to the star than Earth does to the sun. From its surface, the star would loom large in the sky, 3 times wider than our sun appears to us, but glowing, not gold, rather deep ruby red. Its light would carry less energy in the visible spectrum and more in the infrared, painting the world in perpetual twilight hues. If an atmosphere exists, it could scatter that light in strange ways, casting a soft, dreamlike glow across the surface. A day on Proxima b, however, might not resemble any day we know. The planet's close orbit likely means it is tidally locked, one side forever facing the star, the other trapped in eternal night. On the sunlit side, temperatures could soar. On the dark, they would plunge to extremes. But along the border between day and night, the terminator zone, conditions might be just right. There, gentle winds could circulate warmth between hemispheres, creating a thin band of eternal dusk where ice melts and water could flow. If life exists, it might flourish in that twilight ring, a region of permanent sunset where the light never dies and the darkness never fully wins. But everything depends on whether Proxima b holds onto its atmosphere. Red dwarfs are restless, flaring stars, and their radiation can strip away the air of nearby planets over time. If Proxima b lost its atmosphere, it could be a bare, silent rock, its oceans long evaporated, its surface scarred by storms of particles from its star. Yet if it has a magnetic field, something strong enough to deflect those flares, its air could have survived. And in that air, perhaps, clouds drift through the dim red light, and rain falls softly onto alien seas. To imagine Proxima b's temperature is to imagine a scale of possibility. It could be frozen, scorched, or perfectly balanced, a planet of extremes or equilibrium. But hope lingers in the middle ground, for even in the faint glow of a distant red sun, energy still flows, water can still exist, and chemistry can still weave complexity out of dust. Perhaps someday, when we finally glimpse its atmosphere through the lens of a future telescope, we'll see the faint signature of vapor, of oxygen, of warmth, signs that Proxima b is not just another distant rock, but a cradle, a place where the universe itself remembers how to dream of life. Solar flares here are storms of fury, ultraviolet tempests sweeping entire worlds. Yet, if magnetic fields hold, life might find a way to hide in the twilight beneath the shelter of stone and sea. Proxima Centauri, though small and dim by stellar standards, is far from peaceful. Its surface seethes with magnetic energy, coiling and snapping like an invisible storm. These flares, immense bursts of charged particles and radiation, can erupt without warning, brightening the star hundreds of times over in a matter of minutes. For a nearby planet like Proxima b, such an event would be catastrophic. A single flare could flood its skies with X-rays, tear apart molecules in its atmosphere, and bathe its surface in sterilizing ultraviolet light. We tend to think of the sun as stable, but Proxima reminds us how fragile that stability truly is. Red dwarfs are notorious for their tempers. Their cooler temperatures and smaller size allow magnetic fields to dominate their behavior, tangling into loops that twist until they snap, releasing energy with the power of millions of atomic bombs. These are not rare events, they are routine, a heartbeat of chaos pulsing through the life of the star. If Proxima b ever had an atmosphere, these flares would test its endurance. The solar wind, a stream of charged particles ejected from the star, would crash into the planet's magnetic field like waves against a cliff. Without a strong enough field, that wind could erode the atmosphere over time, stripping away the very gases that make life possible. Earth's magnetic shield, generated by molten iron churning deep within, protects us from the same fate. Perhaps Proxima b once had such protection, or still does. If so, its skies may shimmer with auroras of crimson and violet, luminous veils woven by the same storms that threaten its survival. And yet, even under such hostile conditions, life may endure. It has before. On Earth, extremophiles thrive in the unlikeliest places, near volcanic vents, beneath glaciers, inside radioactive rock. Life does not always need sunlight. Sometimes, it survives on chemistry alone, drawing energy from minerals, heat, or the quiet pulse of geothermal warmth. On Proxima b, life might have retreated underground, or beneath the surface of oceans, shielded from radiation by rock and water. There, in the eternal twilight, microbial colonies could feed on the faint trickle of chemical reactions, dreaming beneath a restless sky. For all their violence, red dwarfs offer something our sun cannot: time. While stars like ours burn bright and die within 10 billion years, red dwarfs live for trillions. Even if Proxima b loses its atmosphere and goes silent, the story of such worlds is far from over. New planets may form around younger red dwarfs, and perhaps life, given patience beyond measure, will find new footholds. So the winds of a red dwarf are not just destruction, they are also creation, sculpting, refining, testing. And if somewhere beneath the surface of Proxima b, a single cell persists against the storm, then it stands as proof of a truth written across the stars, that even in the fiercest winds, the universe never stops trying to live. Proxima's glow is faint to human eyes, but in infrared, it burns like an ember, steady, patient, ancient. To life adapted to its warmth, daylight might be a deep and endless red. Our eyes are tuned to the light of our own sun. We see in the narrow band of radiation that filters through Earth's atmosphere, from the violet shimmer of 400 nanometers to the deep red of 700. It is a small window in an infinite spectrum, chosen not by chance, but by the light that has always surrounded us. We evolved beneath a yellow star. Our biology learned its rhythm, our colors its language. But Proxima Centauri tells a different story. Its light hums in longer wavelengths, mostly invisible to us, radiating not brilliance, but warmth. If you could stand on a world beneath Proxima's dim star, you would see a sky perpetually painted in crimson dusk. Shadows would stretch and fade into a red horizon that never truly brightens. To your eyes, it would feel like evening forever, gentle, muted, timeless. But if your eyes could see infrared, the world would come alive. The star would blaze like an ember at the heart of everything, bathing your surroundings in invisible light. The rocks, the soil, even the air would glow faintly with absorbed heat. The night would never be truly dark. Astronomers use infrared to see through the universe's veils, to peer through clouds of dust, to watch stars being born, to trace the faint heat left behind by the oldest galaxies. In that spectrum, the cosmos reveals its secrets. The James Webb Space Telescope was built for this purpose, to capture light too ancient, too stretched by time, for human eyes to perceive. Through it, we can see not just the past, but the unseen, the faint signatures of exoplanets like Proxima b, and the chemical fingerprints of atmospheres that might cradle life. If there is life beneath Proxima's light, it would not see the universe as we do. Its eyes, if eyes exist at all, might be tuned to deeper reds, and far infrared, where our world is blind. Its plants might not be green, but black or dark crimson, designed to drink every possible photon from the meager sunlight. Evolution, ever practical, would shape life to match the glow of its sun. To them, Proxima's faint pulse would feel bright, nurturing, eternal. This light, invisible to us, is the same light that warms the dust between stars and the faint gas clouds that drift through galaxies. It is the quiet radiance of existence itself, not dazzling, but persistent, enduring across billions of years. The universe does not only speak in brightness. Much of it whispers in wavelengths we cannot hear or see. Our senses grasp only a sliver of reality, and yet we call it everything. But Proxima's ember reminds us that the cosmos is vast beyond vision, a tapestry of light and warmth, some visible, most hidden, all connected. Perhaps one day, when our instruments are sensitive enough and our understanding deep enough, we'll finally see the universe as it truly is, not in shades of blue and gold, but in the quiet red glow that has always been there, just beyond the edge of our sight. For most of the journey, there is nothing, no planets, no landmarks, no light but the stars. Yet within that, nothing lies everything, atoms, dust, and history, drifting toward their next form. Between the stars stretches a gulf so vast, it almost defies comprehension. The average distance from one sun to the next in our galactic neighborhood is around 5 light-years, 40 trillion kilometers of near vacuum. To the human mind, this seems like a void, an endless sea of absence. But in truth, the interstellar medium, the stuff that fills this space, is the quiet foundation of everything that exists. Within its thin currents drift the seeds of worlds, the remnants of stars long gone, and the raw material from which future galaxies will bloom. In every cubic meter of interstellar space, there are only a handful of atoms, mostly hydrogen, the simplest and oldest element in the universe. Yet those atoms tell a story billions of years old. Some were forged in the cores of ancient suns that lived and died before our solar system was born. Others condensed in the shockwaves of supernovae, infused with heavier elements like carbon, oxygen, and iron, the very elements that make up our bodies, our planet, our air. Every breath you take once belonged to a star. Every molecule of water, every atom of carbon in your cells, was born from stellar fire and carried through this great in-between before finding its way into you. The space between stars is also home to dust, microscopic grains of rock and ice drifting endlessly through the dark. These particles are the ash of dead stars, the crystalline bones of exploded giants. Over millions of years, they gather into clouds, vast, ethereal nebulae that span light years, glowing faintly in the energy of passing radiation. Within those clouds, gravity stirs again, pulling matter into new shapes. Even emptiness, it turns out, is just the universe catching its breath. To travel between suns is to move through this ancient continuum, a place where time feels slower, where silence takes on weight. A ship speeding through the interstellar medium would occasionally meet resistance, a gentle hiss of atoms against its hull. Cosmic rays, high-energy particles flung across the galaxy, would streak past like invisible rain. Spacecraft would need shielding, not from matter, but from energy, the radiation of the galaxy itself. And yet, this emptiness is not desolate, it is sacred, because in this stillness, the universe keeps its memory. Each atom carries within it the fingerprint of the forces that shaped it, the fusion that made it, the explosion that freed it, the drift that delivered it here. To touch this space is to touch everything that has ever been and everything that will be. When we look at the night sky, we see the stars, not the space between them, but it is that vast, invisible ocean that gives the stars meaning. Without the dark, light has no home. Without distance, there is no wonder. And without the space between suns, silent, patient, eternal, there could be no stars at all. Invisible particles stream endlessly through this darkness, relics of dying stars and distant galaxies. Each one is a messenger, carrying the memory of explosions that birthed the elements we are made of. Cosmic rays are the universe's quiet travelers. Subatomic particles flung into space at nearly the speed of light. They are born in cataclysms, the deaths of massive stars, the violent jets of black holes, and the shockwaves that ripple through galaxies. Long after the explosions fade, these particles continue their journey, crossing millions of light years, brushing past planets, stars, and the thin clouds of interstellar gas. They pass through everything, through spacecraft, through atmospheres, even through us. At this very moment, thousands of them are streaming through your body every second, silent and unseen. For most of history, we had no idea they existed. It wasn't until the early 20th century that scientists noticed a strange form of radiation coming from above, not below. When instruments were lifted into the sky by balloon, the readings increased with altitude. The Earth itself was not the source. The cosmos was. What we discovered was a rain of ancient messengers, still falling upon us from the depths of space. Each cosmic ray carries a story. Some were forged in the heart of supernovae, titanic explosions that scatter the ashes of dying stars across the galaxy. Others may come from even greater distances, perhaps from quasars or active galaxies billions of light years away. Their energies are almost unimaginable. A single proton can strike Earth's atmosphere with the force of a fast-pitched baseball. When they collide with atoms in our air, they create cascades of secondary particles, invisible showers that ripple through the atmosphere like brief, invisible rainstorms. In space, without the shelter of Earth's atmosphere, these particles move freely. A spacecraft traveling between stars would pass through this cosmic drizzle constantly, its hull occasionally pinged by energetic intruders. Shielding against them is one of the greatest challenges of interstellar travel. For every moment of the journey, the ship and its travelers would be bathed in the steady hum of the galaxy's radiation, the faint background whisper of a living universe. Yet, cosmic rays are not only hazards, they are also storytellers. By studying their composition and energy, scientists can trace their origins, revealing where in the galaxy they were born and what kind of stars produced them. Many carry within them heavy elements, iron, nickel, even traces of gold, atoms forged in supernovae and neutron star collisions. When these particles eventually strike planets, they contribute to the cosmic recycling of matter, seeding worlds with the ingredients for life. In a way, we owe our existence to this radiation. The carbon in your cells, the calcium in your bones, the iron in your blood, all were once part of a star that died, scattering its remains into space. Some of that debris was carried on cosmic rays, traveling for eons before merging again into clouds that form new stars, new planets, and finally, us. So the next time you look up at the night sky, remember that it's not empty above you. The air around you hums with visitors from across the universe, tiny fragments of eternity, still falling from the explosions that gave us life. The universe speaks softly, not in sound, but in particles. And if we listen carefully enough, those whispers remind us of something profound, that even destruction, on a cosmic scale, is just another way the universe learns to create again. Until our bodies can cross these distances, our minds already have. Every simulation, telescope, and photon captured by our instruments brings us closer than our feet ever could. Long before our machines touched the edges of the solar system, our imaginations had already left it behind. Long before Voyager drifted into interstellar night, we had drawn maps of the stars, charted the orbits of invisible worlds, and dreamed of walking under alien suns. The body may be bound by gravity, by time, by fuel, but the mind is propulsion without limit. Thought is the first and fastest vessel ever launched into the void. Every telescope we build is an extension of that vessel, a mirror of curiosity pointed toward infinity. When the Hubble Space Telescope opened its eyes in 1990, it became our orbiting observatory, a quiet sentinel above Earth's atmosphere. Through its lens, we saw galaxies so far away that their light began its journey before our planet formed. Then, the James Webb Space Telescope arrived, seeing not invisible light, but in the faint warmth of the infrared, the afterglow of creation itself. In those long wavelengths, it glimpsed the birth of stars, the shapes of worlds, and the delicate fingerprints of atmospheres circling distant suns. Through these instruments, humanity has already crossed the threshold. We've stood on the shores of exoplanets through the data they send back. We've seen the weather of gas giants light years away, their storms spinning beneath alien clouds. We've read the chemical songs of distant skies, the signatures of methane, carbon dioxide, and water vapor. We have even watched the faint dimming of stars as planets pass in front of them, turning tiny changes in light into landscapes of imagination. In this way, every telescope is a kind of ship, its mirrors and detectors our sails, its data the wind. We launch not bodies, but awareness. Every photon that strikes a sensor is a traveler that began its journey billions of years ago, carrying information from across the galaxy. And when that photon lands in a detector, it completes a journey no rocket could ever make, from a distant star to a human thought. We have also built ships made purely of numbers. Supercomputers simulate worlds we cannot yet visit, tracing how atmospheres swirl, how planets form, how gravity sculpts entire galaxies. In digital space, we've flown through black holes, walked the plains of Mars, and orbited Proxima b. The imagination builds bridges that technology will one day follow. So even if we cannot yet sail the interstellar sea, we have already explored it in the most profound way, by understanding it. Our instruments translate the universe's language into data, and our minds turn that data into meaning. In a way, we are already there, standing under Proxima's crimson light, feeling the faint warmth of a sun 4 years away. Because before every journey begins in steel and fire, it begins in thought, a single spark of curiosity that expands faster than light, faster than fear. The body will follow eventually, but the mind is already among the stars. Curiosity is the only engine that never runs out. It burns silently within us, propelling every telescope, every launch, every dream toward the unknown. Long before rockets, before mathematics, before even language, curiosity was already there, flickering in the eyes of our ancestors as they stared at the night sky. They didn't yet have words for the lights above, but they knew enough to wonder, what are those points of fire? Why do they move? What lies beyond them? That spark, that need to know, is the first true energy source humanity ever discovered. Unlike oil, coal, or uranium, curiosity cannot be mined or depleted. The more we use it, the more it grows. Every scientific milestone begins with that same invisible ignition. The James Webb Space Telescope began as a question. So did the Voyager probes, the Mars rovers, the dream of interstellar travel. The equations that describe gravity, the telescopes that catch ancient starlight, the engines that lift us off the ground, all of them are built on a foundation of asking why and what if. It's the one universal instinct that connects every human being who ever looked up and wondered what they were part of. Curiosity has no borders. It belongs to no nation, no race, no time. It drove early sailors to push beyond the edge of known maps, and it drives modern engineers to send probes beyond the edge of the solar system. It's what links Galileo's trembling hand pointing a telescope at Jupiter to a child staring at the stars through a window tonight. The tools change, but the fire doesn't. When we say curiosity is fuel, we mean it quite literally. Without it, nothing moves forward. Without it, science stops asking questions, and exploration becomes nostalgia. Every time a spacecraft launches, it carries not just instruments and metal, but the accumulated will of billions of curious minds. Every discovery, no matter how small, adds a spark to the great human engine, a quiet reminder that the universe is still whispering secrets, waiting for us to listen. And curiosity asks for nothing in return but attention. It doesn't demand certainty or reward, it thrives on the not knowing, the stretch of imagination that keeps us looking further. Even failure feeds it. Every broken mission, every unanswered question is simply a sign that there is more to learn. Perhaps that's why curiosity feels eternal. It has no endpoint. Even if we reach the farthest galaxy, we would still ask what lies beyond. That endlessness is not a flaw, it's a compass. It tells us we're alive, and that being alive means never stopping the search. One day, when our descendants walk the surface of another world under another sun, they will look up at their own sky and feel the same pull we do now, that soft, insistent wondering that began on Earth. Curiosity will still be their fuel, their map, their light. Because in the end, it's not the rockets or the technology that make us explorers. It's the simple, unstoppable question beating at the center of our species. What's next? Between stars, the temperature falls to just a few degrees above absolute zero. Yet, even here, warmth lingers, the faint afterglow of the Big Bang, wrapping the universe in eternal dusk. The deeper we drift into interstellar space, the colder the universe becomes. There is no sunlight to warm our ship, no atmosphere to trap heat, only emptiness, vast and indifferent. At these distances, the warmth of our sun is a memory, a fading ember swallowed by infinity. Here, heat itself becomes rare, precious, a flicker of resistance against the great cosmic frost. The temperature between stars hovers around 2.7 Kelvin, just a few degrees above absolute zero, the point where motion itself nearly stops, where atoms barely tremble. It is the coldest environment imaginable. Yet paradoxically, it is not completely dark or dead. All around us glows a faint, omnipresent light, the cosmic microwave background radiation, the leftover warmth from the birth of the universe. This is the universe's oldest memory, a whisper from when everything was fire. Over 13 billion years ago, when the cosmos was young, it blazed with unimaginable heat and brightness. As it expanded, that light stretched, cooling with time until only this soft remnant remained, a sea of invisible microwaves bathing every corner of space. Even now, those ancient photons pass through us, through planets and galaxies alike, carrying the faint echo of creation itself. To sensitive instruments, the whole sky hums faintly in their frequency, a glow not from stars, but from everything. To exist in this region, the true interstellar void, is to inhabit a silence so perfect that it borders on the sacred. Every particle of warmth, every photon of energy has traveled for eons. A single ray of starlight might cross light years of cold before it brushes against a grain of dust. The emptiness is not absence, but distance, a space where energy takes its time. And yet, this cold is not cruel. It preserves. It cradles the remnants of exploded suns, the frozen husks of comets, the drifting molecules that will one day form new stars. Within this cold sleep, creation waits. It is the pause between breaths, the stillness before renewal. If you could look around with eyes attuned to microwaves, you would see the entire universe glowing faintly, not with the brilliance of stars, but with the quiet persistence of memory. Every corner of the cosmos, no matter how empty, is wrapped in that same gentle warmth. It is the ultimate equality, from the hearts of galaxies to the void between them. All of existence is bathed in the same ancient light. So, yes, space is cold beyond imagination, but it is not lifeless. Even here, where temperatures hover on the edge of nothingness, the universe hums softly with its own history. The cold between the stars is not the end of heat. It is the background upon which all warmth, all life, and all wonder stand out. It is the silence that makes the song of the cosmos possible, a vast, eternal dusk in which every spark still shines. Without landmarks or sound, our only guide is starlight. By tracing subtle shifts in radiation and gravity, we map the invisible highways that connect one sun to the next. In the deep silence of interstellar space, there are no roads, no north or south, no rising sun to mark direction. A traveler drifting between the stars would find nothing to orient by but the light itself, a sky of endless, unchanging brilliance. Yet within that brilliance lies all the information we need to find our way. Every star, every beam, every pulse carries a map written in physics, waiting for us to read it. For millennia, sailors on Earth steered by the stars, letting the constellations guide them across dark oceans. Interstellar navigation is not so different. Only the distances are beyond imagination. Each star's position and motion create a celestial web, a vast framework of reference points that spans the galaxy. The closer and more precisely we measure their movements, the clearer that web becomes. Today, thanks to the Gaia spacecraft, astronomers have charted the exact locations and trajectories of over 1 billion stars in the Milky Way. It is the first true map of our galactic sea, the coordinates of eternity. But light does more than show position. It reveals motion. When a star moves toward us, its light shifts slightly bluer. When it drifts away, it shifts redder, the same Doppler effect that changes the pitch of a passing siren. These minute color changes allow us to measure speed with exquisite precision, transforming distant starlight into a compass. Even the smallest wobble in a star's movement can tell us if unseen planets tug at it, or if gravitational waves have rippled through the space around it. For interstellar travelers, starlight would serve as both clock and guide. Pulsars, the ultra-dense remains of exploded stars, flash with such precise regularity that they function like cosmic lighthouses. Each one spins hundreds of times per second, its radio beams sweeping across space like the ticking of a perfect clock. By measuring the arrival times of these pulses, a spacecraft could triangulate its position anywhere in the galaxy with astonishing accuracy, a kind of galactic GPS, powered not by satellites, but by the remnants of supernovas. Other guides lie hidden in the faint glow of radiation that fills the cosmos. The cosmic microwave background, for instance, can serve as an ultimate reference frame, the true stillness of the universe. Against it, every motion, every acceleration becomes measurable. Even gravity itself leaves trails to follow. The subtle bends of starlight as it passes massive objects curving through the warped geometry of space-time. In the darkness between suns, light becomes both the map and the message. A ship bound for Proxima Centauri would rely not on sight, but on sensors, reading the faint drift of the stars, the delicate pressure of photons, and the invisible tug of gravity. Each photon that strikes its detectors would be a coordinate, a whisper saying, "You are here." So even in a universe without roads, we are never truly lost. The stars themselves are the signposts, the radio pulses the beacons, and the background glow the horizon. Navigation among them is not about finding where we are. It is about remembering what we are part of, a web of light so vast, so intricate, that every beam is a thread leading home. At relativistic speeds, the universe bends around you. Decades pass on Earth, while only moments unfold aboard your ship. The faster we travel, the slower we live. Time, that invisible current carrying us forward, is not as steady as it seems. Einstein taught us that it flows differently depending on how fast we move, how deep we sit in gravity's well, and how we choose to measure the universe. The closer we come to the speed of light, the more that flow begins to twist and warp until what we think of as time begins to resemble space itself. Flexible, stretchable, strange. Imagine a ship bound for Proxima Centauri, accelerating to a significant fraction of light speed. From Earth, the journey would take more than 4 years. But for those aboard, the clock ticks differently. As their speed increases, time for them slows relative to everyone else. Days aboard the ship stretch gently into weeks, while back home, years roll by. To the crew, the trip might feel shorter than the distance suggests, perhaps months or even weeks. They would arrive younger than those who watched them depart, their voyage recorded not only in distance, but in time itself. This phenomenon, time dilation, isn't fantasy. It's been proven again and again. Particles accelerated in laboratories live longer than they should. GPS satellites orbiting Earth must constantly adjust their internal clocks, slowed slightly by their speed and affected by weaker gravity. Even the astronauts aboard the International Space Station experience a few milliseconds less time than we do on the ground. In the cosmic scale, these are hints of a deeper truth. Time and space are threads of the same fabric, and motion stretches them both. At near-light speeds, even the stars would seem to shift and warp. Ahead of the ship, starlight would compress into brilliant blues. Behind, it would fade into red and infrared. The entire sky would appear to distort, curving inward toward the direction of motion, a tunnel of light carved by velocity itself. To move that fast is not just to travel through space, it is to alter the rhythm of reality. And what of the travelers themselves? If they left Earth and reached Proxima Centauri at, say, 90% the speed of light, they might age only a few years, while more than 4 years pass back home. If they turned around and came back, decades might have gone by. Time, for them, would have been stretched thin, a personal, relative thing. This is one of the strangest gifts of relativity. Motion transforms distance into duration, and duration into motion. The faster you go, the less you experience of time, until, at the ultimate limit, time stops altogether. At light speed, photons experience no passage of time between emission and absorption. For them, the universe exists in a single eternal instant. When we dream of interstellar travel, we often imagine it as a conquest of distance. But in truth, it's a negotiation with time, a reshaping of how we experience existence itself. To travel far is to touch eternity in both directions, to see how small a human lifetime is, and yet how vast it can become when it bends the flow of the cosmos. At those speeds, the boundary between when and where dissolves. And the traveler becomes something else entirely, a witness to the pliable, living fabric of the universe. Even when we reach another star, we remain within the same cosmos, the same endless fabric. Every destination only reveals another horizon. For as long as humans have existed, we've been a species of seekers. We travel to find, to touch, to arrive. Mountains, oceans, planets, stars, each one a goal shimmering at the edge of the unknown. But in the scale of the universe, arrival is an illusion. No matter how far we go, we remain inside the same unbroken expanse, a single, continuous field of energy, matter, and time. If a ship were to reach Proxima Centauri, the nearest star to our Sun, it would feel like the greatest triumph in the history of exploration, a new dawn for humankind. Yet, even after crossing 4 light-years of darkness, the view from there would be familiar. The constellations would shift slightly, but the same galaxies would gleam beyond. The same cosmic microwave background would hum softly in every direction. The universe would still stretch endlessly outward, unchanging in its immensity. We would have crossed a border that doesn't truly exist, a line drawn only by our imagination. This is the quiet truth of the cosmos. Every destination is temporary, every frontier a pause between journeys. Even the word beyond loses meaning in a universe with no edges. When we reach Proxima, we will look toward the next star, and then the next. Each discovery will deepen the mystery, rather than end it. We are not moving through the universe, we are moving within it. Participants in a dance that has no finish line. Astronomers see this reflected everywhere. Galaxies race away from one another as space itself expands. The faster they move, the further they recede until their light fades beyond detection. Even if we could travel forever, the universe itself is running away from us, stretching faster than we could ever chase. One day, distant galaxies will vanish from view entirely, their light too faint and redshifted to reach us. What, then, does arrival mean in a universe that never stands still? Perhaps it means something deeper. To arrive is not to stop moving, but to understand where we are, to see with clarity, to listen, to belong. The real destination of any journey is awareness. Every voyage, no matter how far, returns us to the same realization that we are not separate from the universe we explore. We are part of it, carried by its flow, shaped by its forces. So even if one day we step onto the surface of a world circling Proxima Centauri, feel its alien wind against our skin, and watch its red sun rise above an unfamiliar horizon, we will still be within the same grand whole. The same atoms, the same laws, the same endless wonder. Arrival, then, is not the end of exploration. It is its continuation, a reminder that there is no final shore, only the infinite sea, and our eternal will to cross it. As the star swells from a pinprick to a sun, its red glow fills the viewport. After years of darkness, light returns, and with it, the weight of what we've done. We have crossed the interstellar sea. At first, it is only a whisper, a slightly brighter ember against a tapestry of stars. For years, it seemed unchanged, fixed in its place like every other distant light. But as our ship drifts ever forward, that faint spark begins to bloom. Slowly, almost imperceptibly, it grows, its light spreading wider, deeper, redder. What once was just another star now becomes a destination, a beacon, a second home rising from the dark. After endless nights adrift in interstellar silence, the return of light feels almost sacred. The sensors detect it first, a subtle uptick in infrared radiation, a faint warmth on the ship's outer hull. Then the human eye confirms what the data already knew. We are no longer in the void. We are approaching another sun. Proxima Centauri, the nearest star beyond our own. For countless generations, it was a word in textbooks, a dot on star maps, a symbol of the unreachable. And now, here it is, not as an idea, but as light. The first photons from its surface now touch our vessel directly, traveling 4 years through space, only to meet us in this precise moment. That light began its journey before we ever launched. It left before our engines roared, before our mission began, and only now, after all this distance, does it arrive, as if time itself has waited for our meeting. As the star swells in the viewport, its color deepens to a rich crimson. Its glow is softer than our sun's, less blinding, more intimate. It pulses faintly, breathing with the slow rhythm of fusion. Around it, darkness blooms into detail, faint glimmers of dust, perhaps the suggestion of an orbiting world. Every sensor on the ship hums alive, hungry to taste the light, to decode its fingerprints. For the crew, or for those who dream this voyage through screens and data streams back on Earth, this moment is more than a scientific triumph. It is spiritual. We have crossed the unimaginable gulf between stars, and the universe has answered not with silence, but with light. It's as if the cosmos itself reached out to meet us halfway, to remind us that we were never truly separate. And beneath that red glow, emotion wells, a strange blend of awe and homesickness. Because in that light, we see both beginnings and endings. We've reached a new sun, yes, but we've also left our own behind forever. Every arrival, after all, carries the ghost of departure. The instruments continue to record, the navigation systems hum softly, but for a brief, unspoken moment, there is only stillness. The hum of the engines fades beneath the realization that we've done what was once impossible. We've crossed the sea between worlds, following the faintest glimmer through an ocean of night, and found, at last, another sunrise. Light has returned, and with it, the reminder that no matter how vast the dark, there will always be another horizon waiting to shine. Proxima belongs to the Alpha Centauri system, a triple star family. In its sky, 2 distant suns might rise together, painting twin shadows across alien oceans. Most stars in the galaxy are not solitary like our sun. They live in pairs or trios, bound by gravity into intricate cosmic dances. Proxima Centauri is one of them, the faintest, smallest sibling of a magnificent family. Its 2 companions, Alpha Centauri A and Alpha Centauri B, orbit each other in a tight, elegant loop, while Proxima drifts far on the outskirts, a lonely ember circling at a distance where light itself seems to slow. Yet, despite this vast separation, all three stars are bound, an ancient gravitational bond, a celestial family stretched across light years. Imagine standing on the surface of Proxima b, looking up at that alien sky. The primary sun would be Proxima itself, a dim red disk, larger in appearance than our sun but far less bright, casting the landscape in crimson hues. Its light would feel soft, almost liquid, washing the world in shades of deep rust and copper. Then, far away on the horizon, two faint glimmers might appear, Alpha Centauri A and B, shining together like twin lanterns in the night. At times, their combined light could even rival our moon's glow on Earth. On some nights, they might rise and set as one. On others, they drift apart, weaving their eternal duet through the distant sky. Astronomers believe Alpha Centauri A and B are remarkably similar to our Sun, one slightly larger and warmer, the other slightly cooler and dimmer. Together, they make a binary system of golden light, orbiting each other every 80 years. Their radiance, though separated from Proxima by more than 13,000 astronomical units, still bathes it faintly in warmth. In a sense, Proxima b orbits not one, but three suns. Its nights are never truly dark. Its shadows, perhaps, are never alone. From a distance, the sight of this system is breathtaking. Two golden stars whirl around one another in a tight embrace, while far beyond, a tiny red ember keeps its solitary course, the quiet outsider watching its siblings dance. Proxima may be small and faint, but it completes the picture, the third note in a chord, giving the system its balance and depth. To imagine a triple star system is to imagine a world of strange rhythms. Seasons would not follow the simple pattern of light and shadow we know. The sky would be alive with movement, with shifting colors, shifting suns, shifting gravity itself. For any life that might exist there, time would be written in light, the passing of one sun behind another, the long glow of twilight stretching across centuries. And for us, looking toward it from across the void, the Alpha Centauri system is more than just a cluster of stars. It is a mirror, a glimpse of what our own sun might look like from afar, a family of light bound by invisible threads of gravity and time. Three suns, intertwined by destiny, whispering to one another across the dark. It's a reminder that even in the vastest spaces, companionship endures, and that every distant glow in the night sky might not be a single light, but a family, dancing together forever in the slow waltz of creation. Proxima b is likely tidally locked, one side bathed forever in day, the other lost in eternal night. Between them lies a ring of dusk, where warmth and cold find balance, and perhaps life. If you were to stand on the surface of Proxima b, the first thing you'd notice is that the sun, Proxima Centauri, never moves. It hangs eternally in the same place in the sky, unmoving, unsetting, unchanging. On one half of the planet, it blazes endlessly in a crimson noon that never cools. On the other, it never rises at all, a frozen wasteland locked beneath a ceiling of perpetual darkness. But between these extremes lies something extraordinary, a narrow band of eternal twilight, a place where the day's warmth and the night's chill meet in fragile equilibrium. This twilight ring, the terminator zone, may be the most habitable region of all. Here, the temperature could hover near the point where water can flow. Winds from the sunlit hemisphere would rush toward the dark, carrying heat across the border, creating endless storms and gentle mists. The sky would shimmer with deep red hues, the air thick with contrast, one horizon glowing bright and warm, the other fading into star-filled blackness. It would be a world divided not by continents or oceans, but by light itself. Scientists believe tidal locking is common among planets that orbit red dwarfs like Proxima. Because these stars are cooler, their habitable zones lie much closer in, and at those distances, the star's gravity grips the planet tightly, forcing one side to always face its parent. It's the same reason our moon shows only one face to Earth. Over millions of years, tidal forces slow the planet's rotation until it becomes synchronized, its day equal to its year. On Proxima b, that means the same face has been staring into the crimson light for eons, while the far side has slept in shadow just as long. And yet, life could still find a way here. In the twilight zone, energy and stability coexist, the two ingredients life requires most. If Proxima b possesses an atmosphere, it might help circulate warmth between hemispheres, softening the contrast. Clouds could form above the dusk line, raining in cycles driven by eternal gradients of temperature. Beneath those clouds, perhaps oceans gleam like dark mirrors, their surfaces rippled by winds that never stop. Imagine a landscape of perpetual sunset, a sky painted in copper and violet, the horizon burning red, while stars already twinkle overhead. Shadows would stretch infinitely long, changing shape but never direction. The concept of time itself would blur. There would be no morning, no evening, only the slow pulse of weather and light. Plants, if they exist, might have evolved to drink the dim red glow, spreading wide leaves to capture every photon. Animals, if such creatures walk this world, would live in rhythm with the wind, migrating along the edge of twilight, forever chasing the line between life and ice. There is something deeply poetic about such a world, a planet divided yet united by balance, where the extremes of existence cancel each other out, creating a single, fragile ribbon where possibility blooms. Perhaps, one day, when we look through a telescope powerful enough to glimpse its skies, we'll see the faint spectral signature of oxygen or water vapor, proof that somewhere, in the glow between day and night, something breathes beneath a never-ending sunset. In that soft, red twilight, Proxima b may not just be another planet. It may be a mirror, showing us that life, in its quiet determination, always finds its way to the in-between. If Proxima b holds on to its air, it could shimmer with auroras brighter than any on Earth, rivers of light dancing across the horizon, fed by a restless magnetic sky. An atmosphere is more than air. It is a planet's memory. It holds the stories of volcanic eruptions, chemical reactions, and starlight absorbed and scattered over eons. It shields what lies below and reflects what lies above. But for a world like Proxima b, holding on to such a fragile veil may be the difference between a paradise and a silent, airless stone. Red dwarf stars like Proxima Centauri are both generous and dangerous. Their dim, steady glow can warm planets for trillions of years, far longer than our sun will live. Yet their violent flares can strip away atmospheres atom by atom. The high-energy radiation from these stellar tempests batters nearby worlds, breaking apart molecules, ionizing gases, and sweeping them into space. For Proxima b, orbiting so close to its sun, every flare is a trial, a cosmic test of endurance. And yet, if the planet has a magnetic field, it may still stand a chance. Just as Earth's magnetosphere deflects solar wind, creating the auroras we see near our poles, Proxima b's field could weave a similar shield, though under a much fiercer sky. Charged particles from Proxima's frequent eruptions would slam into that invisible barrier, spiraling along magnetic lines toward the poles, where they would collide with the atmosphere in cascades of color and fire. Imagine standing beneath that sky. Curtains of crimson, violet, and emerald light would ripple across the heavens, far brighter and broader than Earth's auroras, painting even the perpetual twilight in motion. The storms that create them might be terrifying in scale, but their beauty would be transcendent, the planet itself glowing with the energy of its parent star. If such an atmosphere exists, it would likely be dense, perhaps rich in carbon dioxide or nitrogen, trapping warmth and protecting liquid water below. Clouds might stretch in permanent bands around the twilight zone, reflecting the dull red light into countless shades of amber and rose. Winds would race endlessly from the day side to the night side, circulating heat across hemispheres, creating an ever-shifting climate where no two moments are quite the same. And within that atmosphere, chemical signatures, the fingerprints of life, might hide. Traces of oxygen, methane, or water vapor could reveal themselves in the faintest changes of light as Proxima b passes in front of its star. These are the clues astronomers on Earth search for: subtle dimmings, gentle fluctuations that whisper of weather, clouds, and perhaps breath. To detect an atmosphere on a world 4 light-years away is no small feat. It requires patience, precision, and the collective will to look longer than seems reasonable. But with instruments like the James Webb Space Telescope, humanity is already beginning to peer into those distant skies. Whether Proxima b breathes or not, its story reminds us that air, invisible, fragile, and fleeting, is one of the universe's greatest miracles. For where there is an atmosphere, there is shelter. Where there is shelter, there is potential. And where potential exists, life, in some form, somewhere, will always try to rise. So perhaps, on that distant world beneath a red sun, winds still whisper and lights still dance. And in those shifting skies, the universe keeps one of its oldest promises, that even in the harshest places, beauty endures. Beneath those skies, there might be water, an endless ocean of red reflections, where alien organisms drift through perpetual evening, thriving in warmth we can only imagine. If Proxima b is anything like Earth, its most precious element would be the simplest: water. In its liquid form, it is the great enabler of chemistry, the quiet architect of life. On a world orbiting a red dwarf, that liquid could take on unfamiliar hues, glowing with the reflected light of a dim crimson sun, shimmering like molten copper under a sky of perpetual dusk. Imagine an entire planet bathed in red, its oceans calm and heavy, whispering against alien shores. The existence of such oceans depends on delicate balance. Too much stellar radiation, and water evaporates into space. Too little, and it freezes into glaciers that never melt. But if Proxima b's atmosphere is thick enough, if it shelters its surface beneath layers of warmth and pressure, then liquid water could persist, perhaps flowing in vast basins or even covering the world entirely. This possibility alone keeps astronomers dreaming, because where there is water, the door to life opens just a little wider. In these imagined seas, the rules of light and color would transform. Under the red glow of Proxima Centauri, blue wavelengths would be scarce, swallowed by the water almost instantly. The depths would not fade into blue darkness, but into a deep maroon, a kind of liquid night. Organisms here might evolve pigments tuned not for sunlight, but for infrared, absorbing the faint warmth that filters through the waves. Perhaps translucent creatures drift near the surface, glimmering like glass, while others below glow faintly with bioluminescent light, painting constellations beneath the waterline. Currents would flow in ways unlike any we know. The heat from the eternal dayside would drive warm winds and tides toward the night, where the waters might freeze into endless ice. The border, the twilight ocean, could be a place of ceaseless motion, where vapor rises, condenses, and falls again as rain. Thunderheads might bloom like red roses over the horizon, lightning flashing through copper clouds. Rain would fall in slow, shimmering drops, staining the sea in reflections of the star above. Even the soundscape would be alien. With no moon to sculpt tides, waves might roll endlessly without rhythm, stirred only by planetary winds. Beneath, the hum of geothermal vents might echo, the deep heartbeat of a living world. Around those vents, as on Earth, life could thrive independent of sunlight, drawing energy from minerals and heat. Microbes might cluster in filaments, feeding and glowing softly in the dark. If oceans truly exist on Proxima b, they may have persisted for billions of years, long enough for life to arise, adapt, and evolve under their red-tinged skies. Perhaps not intelligent life, but something gentle and patient, as ancient as its star. Something that has never seen blue, never known night, and never needed to. And if someday human explorers arrive, whether through telescopes or starships, and they find those seas glinting in the crimson light, it will not just be discovery, it will be communion. A meeting of two oceans, one from a world of golden days and one from a world of endless twilight, touching across the vast dark in shared reflection. For even across 4 light years, the dream of water endures. It is the universe's oldest memory, and perhaps its most beautiful promise. If life exists there, it has never heard thunder, never seen blue. It has evolved in crimson twilight, in silence so deep, even sound itself seems sacred. On Proxima b, everything would move slower, softer. The air, if there is any, would be dense and heavy, muffling every vibration. The oceans would roll in long, silent waves beneath skies that never brighten, never darken. There would be no lightning storms, no roaring wind, no crash of thunder. Instead, there would be a hush, an eternal calm stretched across a world that has never known noise as we do. Here, life would grow in rhythm with the stillness. No creature would call across the void. No leaves would rustle under wind. Instead, communication might happen through chemistry, pulses of scent, waves of temperature, slow bioluminescent flickers in the dark. Sound might be unnecessary, or perhaps sacred, reserved for moments of great significance, like a heartbeat in a cathedral. On Earth, the noise of life is constant. Our planet hums, roars, sings, every gust of wind, every chirp and ripple, a vibration through the air. But on a tidally locked world orbiting a dim red sun, the concept of daytime sounds might not exist at all. If there are forests, or something like them, they would sway in complete silence. If there are seas, they would murmur faintly beneath an atmosphere too thick to carry echoes. Even footsteps, if ever taken there, would fade instantly into the dust. And yet, silence does not mean emptiness. It means focus. It means that the smallest motion, a droplet falling, a bubble rising, a leaf trembling, could become profound. On such a world, life might experience existence not through sound, but through vibration, through light, through the gentle tug of gravity and current. It might feel the universe rather than hear it. If we could stand there, beneath the dim red glow, surrounded by air thick as velvet, our own voices would sound alien. Words would carry only a few meters before dissolving into the stillness. We would hear our own breathing more than anything else, the quiet rhythm of life that connects us to everything living, everywhere. Perhaps this silence is not absence, but reverence, a kind of cosmic meditation. In that stillness, life could evolve without haste, without competition, without the chaos that fills our blue world. Each moment would stretch wider, each movement deliberate. Existence itself would slow to match the calm pulse of its sun. And if intelligence were ever to arise there, if some being looked up at the same crimson sky and wondered as we do, its thoughts might be shaped by the stillness around it. Its language might not be spoken, but seen, flashes of colour, glows of meaning, gentle patterns of light upon the air. The silence of Proxima b would not be empty. It would be profound. It would be the stillness of a world that listens more than it speaks, a planet in perfect conversation with its star, its seas, and its endless red sky. And perhaps that's what the universe is teaching us through such worlds, that not every form of life must sing to be alive. Some merely exist in quiet grace, their silence echoing across light years, reminding us that in the vastness of creation, peace itself can be a kind of music. When we finally arrive, we will be the strange ones, beings of blinding light and fleeting lifespans, stepping onto a world that has never known our kind of sun. For so long, we've looked up at the night sky and asked, are we alone? But perhaps the deeper question is this: what happens when we are the ones who arrive? When we become the distant visitors descending upon another world, not as myths or invaders, but as travelers, fragile and curious, bringing the light of a foreign sun in our eyes. To the life that might exist on Proxima b, we would be as unnatural as the dawn. Our presence would break every rhythm that world has ever known. Our voices would shatter its sacred silence. Our lights would pierce its eternal twilight. To them, our machines would hum like thunder. Our movements would seem impossibly quick. Even our brief lives, measured in decades rather than millennia, would be a kind of flicker. We would come and go before the red sun had shifted in its slow, ancient cycle. Imagine what it would mean to set foot on that surface. Beneath skies painted in crimson dusk, our shadows would fall sharp and alien. The faint winds, tuned to gentler harmonies, would recoil from the stir of our breath. The soil beneath our boots might never have felt vibration in eons, and now, suddenly, it would tremble. For generations, we've imagined aliens as things unlike us, beings of strangeness and mystery. But in the mirror of the cosmos, we are those beings. We are the ones who leave our world behind, who arrive under foreign suns with strange technologies and stranger hopes. Our bodies carry the microbiomes of Earth, invisible stowaways from oceans, clouds, and skin, a symphony of life no other planet has ever heard. Wherever we go, we bring an entire biosphere in miniature, woven into our cells. And perhaps that's the beauty of it. To arrive not as conquerors, but as carriers of light, fragments of another star, crossing the sea to meet its neighbor. If we ever touch that soil, our first act will not be to claim it, but to listen, to kneel in the red dust and let the universe speak through the stillness. To any eyes watching us, biological or not, we will appear as impossibilities. Fragile creatures wrapped in metal shells, hearts beating fast, minds racing faster. We will seem temporary, ephemeral, and yet so full of intent. Like lightning in slow motion. Maybe this is how first contact always feels, not as revelation, but as reflection. The realization that in every galaxy, in every age, the visitors are the same, small, curious beings reaching for something greater than themselves. When we finally arrive, the word alien will lose its meaning. Because standing beneath Proxima's red sun, we will understand we were never separate from the universe we sought. We were always part of its story. We were always the travelers, the questioners, the fleeting sparks of awareness lighting up the endless dark. And perhaps, in that moment, the universe will look back and recognize us. Perhaps we'll leave a record, etched in metal or light, of who we were, so that one day another civilization can find it and know we once reached for their star. Every great voyage begins with a message. The Voyager probes carried 2 golden records engraved with the sounds and images of Earth, greetings in 60 languages, the hum of wind and rain, the heartbeat of a mother and child, the laughter of humanity echoing across interstellar space. Each record is both artifact and offering, spinning now in the dark, waiting to be found. They remind us that even when we cannot go ourselves, we still send pieces of who we are. If we ever reach Proxima Centauri, we will bring that same impulse with us. The desire not just to explore, but to be remembered. Perhaps our first act on another star will not be to build, but to leave something behind. A monument, a code, a whisper written in materials designed to outlast the ages. Maybe a small plaque sealed in titanium, bearing no flag, no ownership, only a message that says, "We were here, we looked outward, we cared to know." In the vacuum of interstellar space, time stretches differently. A simple engraving, a digital crystal, or a beacon encoded in photons could survive for millions of years, long after we are gone. It could drift in orbit around Proxima b, or sit quietly on its surface, waiting. Perhaps it would hum faintly, powered by starlight, transmitting once every century a simple tone, a heartbeat of civilization. But what would such a message say? Would we fill it with facts, the elements of our world, the structure of our DNA, the maps of our constellations? Or would we write something simpler? A story, a song, a phrase that captures what it meant to be human. Maybe it would be something like this. We were creatures of a small blue planet that orbited another star. We dreamed of others like ourselves. We crossed the dark not for conquest, but for connection. We often imagine these records as time capsules for other beings, aliens, far in the future, who might stumble upon the relics of our curiosity. But perhaps they're meant for us, too, reminders that we were once capable of such wonder, that we looked beyond the boundaries of our world and chose to leave behind not monuments of power, but traces of hope. And if, one day, another civilization finds our message, whether they are biological, mechanical, or something beyond imagination, they will know this, that across 4 light-years, across an ocean of silence, a small species dared to send its voice. Maybe they will listen, maybe they will answer, or maybe they'll simply smile, in whatever way their kind does, and understand what we meant when we reached for the stars. Because no matter how far we travel, or how long we last, every voyage is also a message, that the universe is not empty, because it contains us. The beings who wondered, who dreamed, and who cared enough to leave a light behind. Looking back from Proxima Centauri, our sun is just another point of light. Home becomes a memory smaller than a grain of dust, but no less precious. From here, across 4 light-years of distance, the sun is no longer a blazing disk that fills our sky. It's a faint, golden spark among billions, a single ember flickering in the deep. All the colours of our oceans, the forests, the storms, the songs of our civilization, everything we've ever been, compressed into that one trembling point. It doesn't announce itself as home, you would only know it by memory. It's humbling and beautiful to realize that from this distance, our entire world could vanish behind the smallest mote of dust. The boundaries that once felt vast, nations, continents, even the orbit of the moon, blur into invisibility. What remains is unity, one planet, one light, one fragile refuge, suspended in the dark. This is the truest gift of exploration, not escape, but perspective. The farther we go, the more we understand how extraordinary our home really is. We chase the stars not to leave Earth behind, but to see it more clearly. When you look back from the edge of another sun's influence, you don't just see where you came from, you feel it. You realize that the air, the warmth, the gravity that shaped you are not universal laws, but miracles of balance. To stand beneath Proxima's crimson glow and look toward the faint sparkle of Sol is to feel the vastness of our journey. The light that reaches your eyes left home 4 years ago. The people who waved farewell when you departed have aged, changed, grown, perhaps vanished. The Earth you remember no longer exists as it was, and yet, in this moment, you can still see it. Time and distance blur into a single vision, light as memory. The perspective works both ways. From Earth, we gaze at Proxima Centauri and imagine the unknown. From Proxima, we look back and remember the known, and both views are part of the same truth. The universe doesn't care about here or there. It only offers everywhere. Every world, every star, every atom belongs to the same unfolding story. And in that story, our sun, tiny though it appears, carries something unique. It is the only star we know that nurtures life, that reflects thought, that dreams through the eyes of its children. It is, in all this darkness, a lantern of consciousness. So, as we look back across the interstellar sea, that little spark is more than just a point of light. It's everything. It's laughter and loss, mourning and memory. It's the sound of rain, the scent of pine, the warmth of another human hand. It's the place that taught us to look up. From Proxima Centauri, our sun may look small, but to us it is infinite, because in the great silence of the cosmos, that light is not just our origin, it is our reminder of what it means to belong. Each star we reach becomes the starting point for another journey. Exploration is not a mission, it's a rhythm, repeating forever across the galaxy. The universe has no center, only continuations. Every arrival is a new beginning. Every discovery, a seed for the next. When we look up and trace the Milky Way's silver river of light, we're not just seeing stars, we're seeing the stepping stones of eternity. Suns calling to one another across billions of years. Humanity's voyage from Earth to Proxima Centauri is only the first heartbeat in an infinite rhythm, a movement written into the cosmos itself. If one day we establish ourselves beneath Proxima's red sun, we will soon look outward again. From there, Alpha Centauri A and B will blaze in the sky, bright and inviting. The same question that once stirred us on Earth will rise again. What lies beyond? Because curiosity does not rest when it finds answers. It expands endlessly. It is the same force that moves galaxies, the same pull that draws matter into stars. In time, our descendants may spread from Proxima to other systems, to Tau Ceti, Epsilon Eridani, TRAPPIST-1, and beyond, each one a new outpost of wonder. They will build ships that cross not in decades, but in days. And perhaps, as they sail from one world to the next, they will carry stories of their origins, of a small blue planet orbiting an unremarkable star where everything began. Every star we reach becomes another lighthouse in the night, a place where life pauses to listen before moving on again. And with each new world, our understanding deepens. We start to see the pattern, stars forming, burning, dying, and giving birth to new ones, each linked by the same cosmic thread of energy and time. We realize that our journey is not separate from this process. We are part of it. We are the universe, learning to cross its own distances. Perhaps one day, when the Milky Way's spiral arms are lined with the light of civilizations, we'll understand that exploration was never about conquest or discovery. It was about continuity. The instinct to reach, to learn, to move, it's the heartbeat of creation itself. Even now, the rhythm continues. Photons from distant suns strike our telescopes. Data travels through the void. Human imagination fills the gaps between them. The chain of suns has already begun to pull us forward, link by link. We will never stop, not because we are restless, but because the universe calls to itself through us. Every spark of consciousness, every dream of another sky, is part of the same endless conversation. And when, someday, another species looks up from their own world and wonders if anyone has ever walked beneath different stars, they may find our traces, tiny relics of curiosity scattered across the galaxy. And they will understand what we too discovered, that there is no final destination, only an infinite chain of suns and the unending journey between them. Our descendants may never live under one sky. They will be children of many suns, scattered across light years, connected by stories, not distances. There will come a time when home no longer means a single planet, when the blue marble of Earth becomes a legend, a name spoken softly in classrooms orbiting other stars. The future of humanity, if we endure, if we evolve, will not be bound to one place. It will be woven among countless worlds, each one a thread in the vast tapestry of our becoming. Imagine it, generations born beneath red, yellow, and white suns, children whose lullabies are sung in artificial gravity, whose first sunsets are not blue but violet, whose constellations are unfamiliar. They will not remember the smell of rain on soil or the rhythm of Earth's tides. But they will know something deeper, the feeling of belonging to the stars themselves. On one world, perhaps under Proxima's dim red sky, settlers will walk in the glow of auroras that never fade, growing food under glass domes warmed by captured starlight. On another, orbiting a bright yellow star, cities will drift on oceans that rise and fall with alien moons. On yet another, humans will burrow beneath ice, listening to the creak of frozen continents and calling it home. Each of these worlds will shape them differently, their bodies, their minds, their myths, until human becomes not one form, but many. Distance will no longer divide them. Communication will travel slower than thought, but the stories, the ancient memory of where it all began, will endure. They will remember the first voyage, the leap from Earth to Proxima, told not as a mission, but as a moment of awakening. A story of a species that refused to stay in one place, that carried its dreams farther than any before it. Their calendars will not count years, but journeys. Their history will be measured in light, how far their ancestors' signals have traveled, how many suns now hold the echo of a human voice. And when they speak of family, they won't mean a single bloodline or planet. They will mean everyone, everywhere, the descendants of Earth, scattered yet still connected by curiosity, by gratitude, by the quiet understanding that they are part of the same beginning. There will be no single civilization then, only a constellation of them, a network of light and culture and memory spanning the stars. Some will forget the details of their origins, others will preserve them in song or art, but all will feel, somewhere deep within, the pulse of the same question that carried us from the oceans to the stars. The future that waits between the stars is not a place, but a continuity. The next verse in a story that began when we first looked up and dared to wonder. And when our descendants gaze across their many skies, they won't see separation, they'll see connection, a living web of suns, each one carrying a whisper of where it all began. And far away, faint but enduring, Earth's light will still shine, the first spark in a galaxy of children learning to call the cosmos home. Because the moment we touch another star, we will look beyond it. We are travelers by nature, dreamers by design, and the universe is our reflection, infinite and awake. It has always been this way. From the first humans who crossed unknown seas guided by the stars, to the scientists who now listen for faint signals from the edge of time, we have never stayed still for long. Curiosity moves through us like gravity, pulling us forward, drawing us toward horizons that constantly retreat. Each discovery is only the beginning of another question. Each arrival, another departure in disguise. Even standing beneath a new sun, humanity will not stop wondering. We will gaze out from Proxima's red light toward the next point of brilliance, imagining its worlds, its moons, its possibilities. The urge to explore is not about need, or conquest, or even survival. It is something more fundamental, woven into the structure of consciousness itself. Perhaps one day, our ships will no longer rely on sails or engines, but on understanding, bending space-time, slipping through folds of reality, traveling not through distance but through knowledge. We will send our minds ahead of our bodies, our light ahead of our minds. Each generation will push the boundary further, not because there is something out there to find, but because there is something within us that needs to reach. When we look at the stars, we are not just seeing the universe, we are seeing a mirror. Every spark of light is a reflection of the same fire that burns in us, the fire to exist, to grow, to understand. We are the cosmos becoming self-aware, the atoms of long-dead stars learning to look back at themselves and ask. The journey, then, is not about distance at all. It is about awakening, the slow unfolding of awareness across the fabric of space and time. Every step we take into the dark brings light with it. Every question we ask illuminates the unknown just a little more. And maybe that is the true purpose of the stars, not to be reached, but to be remembered, to remind us that we are part of something immeasurable, something that is always becoming. When the last explorer looks out from the edge of the galaxy and wonders what lies beyond, they will feel the same thing our ancestors felt when they first looked up from the fires of Earth. A sense of endlessness, of belonging, of motion. For the journey has no end, it loops back upon itself, each traveller passing the torch of curiosity to the next, until every star has been touched by wonder, and still there will be more. Because in the end, we are not separate from the universe at all. We are its continuation, its dream, its way of travelling through itself. We began beneath our familiar sky and learned, step by step, what it takes to travel outward, leaving the thin blue veil of Earth, crossing the familiar orbits of our neighbours, and slipping through the heliopause into the slow, solemn dark between suns. We imagined engines that turn centuries into decades, sails that ride light itself, and tiny craft that carry our curiosity farther than our bodies ever could. We traced the soft, red glow of Proxima Centauri and the fragile possibility of Proxima b, a tidally locked world of permanent day and endless night, where a ring of dusk might cradle oceans and life adapted to perpetual evening. We listened to the quiet currents of cosmic rays and magnetic tides, and we held in our minds the smallness and preciousness of our home as seen from another star. Remember, the true journey was not only measured in kilometers or years, but in perspective. From Proxima's shore, our sun will be a distant ember, a reminder that home is both far and intimate. We imagined leaving messages in metal and light, seeds of memory for some future discoverer. We considered how curiosity fuels every engine we build, and how gratitude grounds every explorer when the universe grows wide. Now, breathe slowly. Let the steady rhythm of your breath mirror the calm of interstellar night. Picture the gentle red twilight of an alien dawn, the hush of oceans that have nothing to prove, and the vast, patient silence that holds them both. Be grateful for the small warmth of Earth beneath you, for telescopes that reach across time, and for the mind that dreams beyond the horizon. As your eyelids grow heavy, let the thought of stars fold around you like a soft blanket. Drift outward, safely, into sleep,